Now, polar molecules such as water exhibit fascinating structural patterns. Notice the polarity, and I've kind of cleaned it up a little bit where it's more obvious. If you wish, the outside electron for the top for each of the hydrogens there is the one provided by the hydrogens. And the inside two were provided by the oxygen. But you see, you have your magic 8, which again is important for illustrating that this is quite a balanced compound. But again, it's very positive on the top because it's hydrogen, which is positive, and very negative on the bottom because there's nothing but electrons there. This gives it a characteristic called polarity. Now, polarity is really, really important characteristic in nature, and it's not discussed a lot. Water molecules have an attraction for one another. In other words, the positive end of the hydrogen that you can see there will attract to the negative end of another oxygen in a water molecule. Now, why is that important? Water is amazing in that it has a factor called surface tension, or well, I'll give you an illustration. Take a plate and put several drops of water. Don't pour a bunch of water in, but put several drops of water and run your finger slowly through the water. And notice that the water tends to follow the other water molecules. This characteristic allows a lot of things in nature. The surface tension you're familiar with, for those of you that like to swim. No offense, but if you jump into water, you should sink like a stone, primarily because your relative density is considerably greater than water. But you notice that you don't. Water resists your pressuring it because it wants to adhere to the other water molecules and allows you to float and swim. Illustration. Get yourself a bowl and fill it about half or 3/4 of the water. Take a paper clip and unfurl the paper clip to where it's, spread out pretty wide, but it's still level. Make sure it's very level. And then take a pair of tweezers and carefully set it on top and see if it floats. Now, there's no way in God's green earth that it should float. It should sink like you, as a stone. But you'll find if you do it carefully, it'll actually float. The surface tension of the water allows the metal to float because the water molecules would rather adhere to one another than let the metal float through. Now, how is this so important in nature? The application that's most widely heralded is the giant redwood. Now, a giant redwood gets a couple 100 feet up in the air, which is a long way that you're falling, you know that. But the redwood tree has a very limited root system, probably no greater than 15 feet below, and it interweaves with the surrounding trees and allows it to exist. But how does the water get from the bottom of the 15-foot root all the way a couple 100 feet up in the air to a leaf? Now, we don't have any trained squirrels on the side of the trees in their squirrel cages pumping that water up and down, though I'm sure the trees might appreciate it. That doesn't occur in nature. What in the heck allows the water molecule at the top of this giant sequoia to evaporate and another molecule to be drawn up into the leaf? And that is the factor, which I mentioned before, is surface tension, called capillarity. Again, it's given a lot of names, but it is no more complicated than the polarity of one molecule of water being drawn up by the next molecule. The energy released when the water evaporates draws up the next molecule. And you have a stream of water over 200 feet high. Gravity, of course, doesn't like that much because gravity tries to draw everything towards the center. So my contention is that water exhibits characteristics which are phenomenal in nature and allows you to exist too, because water interacts in your body, allowing a lot of interesting things to occur. Again, water, very important substance. Now, water is a substance, dominates general chemistry. As a matter of fact, first semester of general chemistry, especially if it's not a mathematically complicated general chemistry, is often referred to as water chemistry. And most students see it that way. Now, interjecting math complicates matter, and we'll talk about all the different facets of mathematical interjection, from balanced equations to significant figures to a lot of other things as we go through all these concepts. Let's